My name is Corbin Kingston. I'm part of 893 in our Arsenic, and we've won a bunch of judged awards, including Innovate at State and the Design Award at the international competition. And we're just going to be going over the engineering notebook and what a good notebook will have inside of it. And this is just a brief overview. So first, we've got identify the problem. So every year, the game is different, so you're not going to be identifying the same problem over and over. But the game uh, the game needs to be identified, and then also what type of aspect of the robot that needs to be solving that problem. So you come over here. So obviously we got the identify game problem. We've got the entire game. You just go literally search through the rule book and just go absolutely every single thing you have, like dimensions, anything, how they're scored, how many points they're worth, and you'll just go through that. And then violations, stuff that's important because violations change every year. There are some that are the same, like pinning and not taking part of the robots. But there's a lot of other stuff that you need to look for, like scoring rules. Those are big, very important. And then after you do that, you'll go on to the game strategies. And it's kind of like you want to break down what's the most important, or what are you going to emphasize in your design. And for us this year, we wanted to do the wall stakes and the mobile goals because those could be repeated over and over and over. And that allowed us to get several points in rapid succession. But the ladder, you can see 12 points for the highest tier climb. That thing is that can only be due once at the end of the match, and it's pretty hard to get up there, so we didn't really want to emphasize that. And then you'll have going to the robot design, detail at the start of each design. You come down here to the identify problem for the drivetrain. So the problem statement obviously is we've got this to move it around. And we also took into account the size of the field. So we had a large field, very unobstructed. So you wanted to maximize acceleration because you'd be able to move very quickly, especially because the mobile goals, they're 4 pounds or 3 pounds. One of the heaviest they've released in the past couple of years compared to the other ones that we have. And you basically just wanted to emphasize the acceleration and the torque, kind of. That's definitely part of the identify the problem is what do we have to get around? And then you come up with the brainstorming diagram or prototype solution. So first off, it starts with a brainstorm. Obviously, we looked at all previous tank designs, or we looked at all previous designs. And this goes into account for independent inquiry. So basically, another large aspect of the notebook is independent inquiry. So you have to be willing to go out and look at different designs of robots from previous years and basically able to record all that stuff and put it down into here and look at the pros and cons and does it fit your specific requirements that you listed in the identify problem. Then we'll go on to the diagramming and prototyping solutions. So if you go down here, diagramming. Oh, so this is select best solution. We've got all the solutions listed down here. And then you want to use an engineering design matrix. It's literally a keyword that the judges look for. And it basically justifies why you're picking the solution other than just saying, we want this one because it's the best. You show them why it's the best. Obviously, you put all the categories: mobility, adaptability, build space, defensive power. And the thing is, the more criterias you have, the better it's going to be because you're going to be able to justify it more. And the judges look for why does doing this help your team? When we were getting interviewed at the high school state, one of the judges, we were talking about coding, and they're like, why does this help you? So we had to list that. And then we talked about coding. We talked about data testing. They're like, why does this help you? It's something really important they look for. So you got to be able to justify how does it benefit your team? And that's a lot of stuff that we'll come into later. Next, you go into build and program the solution. A very big thing you need to look at is includes enough detail that the reader can follow the logic. So this is pretty massive. So if you come down here and you look at all our CADs right here, we've got CADs listed out kind of like a prototype. And CADs are pretty well because you can look at every piece individually. But sketches are kind of a little harder because if the person doesn't have any experience with like looking at sketches, it's pretty hard to look at and understand. But with this, it's like you put it right there and they're able to look at everything because it's in color. They don't have to discern like which lines are which because everything's already laid out for them. Then we go down and you have to build the solution. This is the part where it comes back to being able to follow the logic. We're giving them all the pictures and stuff and all the moves that we did to build the robot because it shows them like if someone wanted to repeat this design, this was going to be how you would do it. And you can look at the build instructions, like every single piece, we always list out like what we're doing. Now, a big thing is test solution. Massive, 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 massive. You can change your robot. Like you'll be building all your robot, and you're like, dog, this is pretty bad. And you're like, okay, we'll change it. But then you'll get to the judges and they'll ask like, why did you change this? And you don't have any reason to back it up. This helps you back up your claim that this sucks. So you basically create a claim, say like, oh, this isn't good. We need to change it. Why do you need to change it? Because of this data. So first, what you should do is always, always record all the steps to test the solution. This is basically making a procedure. For our drivetrain, the procedure we had is listed here. And then you have to record the data. For ours this year, it was mainly just like stopwatching and stuff. And you just stopwatch, you take it and put it into a sheet and record the average time. It is pretty big to go into a sheet and put it down because then when you're doing judging, they'll come over and you'll flip around the laptop. You'll be like, one person's talking about all the data you have, and you're like, here's the data, and you'll have proof other than just like generated numbers. And it is best to not fake your numbers because number one is if you fake it bad, the people are going to know. And also faking it does not benefit your team because if you fake it and like the numbers are like super good, but the thing actually sucks, and then you go and change it, they're going to ask you like, why did you change it? And you say, oh, because it was bad, because we wanted to improve upon it, but it was really because it kind of sucked. Now, then you go into repeat the design process. So it's basically the same thing we went over is just repeat. And we did this on the intake several times. So if you look at here, we've got the intake and everything's basically finished. But then after you do some testing, some data collection, some like using it in regular matches, you're going to want to change it. So first off, list your design modifications. And this will basically allow you also like what I said earlier with building is like you follow the logic, create an explanation of your problem, what you're experiencing, and basically how you want to solve that. And then after you solve that, you show the evidence, you show before and after, and then you'll go into more testing. So here is a good example. Intake height, we just wanted it to be a little shorter because it was a little too tall. So that's listed all in the problem statement. Then we explain the proposed solution. And then you show the executed solution before and after. Pictures are always pretty well because just looking at this, like no one's going to come over here and just like want to read a whole entire thing, an explanation of how you changed absolutely everything. Pictures are key. You'll look right here and everything is super, super simple. You don't want it to be like super long because no one's going to sit there and look at it for the entire time. And even when we do observations, these are obviously a little bit longer than just brief bullet points, but you don't want it to be like full paragraphs of explanations of absolutely everything. You just really want to try to limit that, but there is a good balance between data points. I mean, there's a good balance between points and between like paragraphs of explanations. Let me see if yes. So we have here this conclusion, and the main reason why we did this is because if you just do bullet points the entire time, and you simplify everything, you're not going to give them like the full information they need to know. And plus, it takes up a little bit more space if you do paragraphs. And like here, just a conclusion, like these two conclusions right here wouldn't have been enough to support everything we've seen. So it's always explanation and kind of why it helps you, and you want to really justify everything you do. I've got to say, record of team and products management is also pretty big. If you guys don't have a personal team Discord, please set one up. And if you can't, you can still go to your email, and you'll be able to create like a folder, several subfolders in that. You can do like folder, blah 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 team channel, and you'll have several different like subcategories of stuff like notebooking, engineering, blah blah blah. I'll actually quite show you this what I have right now. Let me just stop sharing this, and I'll share absolutely. Yeah. Actually, I'll go over that right now. So it would be better if I show you the intake data, because that's where we actually came into most of the data points. Let me see if I got it. Ah, yes, here it is. Here it is. Okay, so mean is the average. Median is just like the center, or I think the most common one. The only reason I actually put it in there is if you guys took POE, or if you are going to take POE in ninth grade, you go over data analysis kind of, and that's what class I took, and that's the role I play on my team. I do data analytics and project management. So the range is like, the standard deviation basically shows like if you have lower standard deviation, the more consistent your stuff is. So let's say like the standard deviation was 1, that'd be pretty bad, but the lower and lower you go, the better and better and more consistent that aspect of your robot is. Does that make sense? Okay, so let's go into team management. I'll go into my personal 8931R Arsenic. Don't mind all these pictures, but basically we have general, basic stuff. Then we go into designs, whether that be like stuff we're planning for our Worlds banner right now, but we also have robot designs. Then we have strategies, where we'll go over robot strategies. You really want to be able to watch matches. So do any of you guys know what signature events are? Okay, so you want to be able to, if you can, get a phone stand and set your phone up on the corner where usually your bot sits and stuff, and you want to record the full match. So that will allow you to, like, whenever you have to change code, you're like, that just didn't work. And you want to be able to pull up a video and see why it didn't work or what went wrong. You'll be able to change your code. And then you'll also be able to analyze what you did right or wrong in a match. And now I'll go down to our match analysis. Here, find it. And we'll go over Cav Cup elims. So we went into Cav Cup, we won 8-1, and we'll list all the matches we have, and then we'll list like some certain quals that we think were important. And you want to go over what's good, what you did bad, and what you can improve. And that will basically show how you're developing your game strategies. We had our interview for the World Championship not too long ago, and they asked you, can you tell us how your robot strategy for the game has developed over the season and stuff? And you'll go over and you'll talk about all your stuff. And that's what we have here is like we analyze our own matches as well as other matches. If I can find, we looked at signature events, and basically what is that is it's just like pretty large, like it's basically just like the best of the best people come to a competition. So you look at here, we have MOA, Mall of America signature event that took place early in the summer. And that's a really big one. is because those are the best of the best teams. And then as the game develops, we continue watching more and more signature events because those are the best of the best. And if you can replicate the best of the best, you become the best, basically. And that's how we were able to reach finalists in the high school championship. So it's watch your own matches, watch other matches, analyze strategy. If you guys can get on like online and talk to people about strategies and just watch other people's videos, that's pretty massive because it really helps you improve upon your strategy. But this isn't only just for like driver strategy. You also want to be looking at skills, auton skills, match autons as well. Because a lot of people, they'll post theirs. I know if you go to Robolytics, I can post that later in the Discord. You look at it, and people do robot like auton ratings and stuff, and people will post their full autonomous, and you can just like take pieces of that and like Frankenstein your own like route you need based on the specs of your robot. And we'll go here. I'll go off more and more. So you basically just see we've got the group Discord. You can do this in an email, and you want to break up absolutely everything. Because if you just have one email and you're sharing all the information, you don't want to be scrolling through the entire thing the entire time. That would be very tedious. Now, if you see here, we have August overview. You'll have a calendar. Let me see if I can pull up a calendar that. Yes. So we use a calendar. Basically, the reason why you do a calendar is you want to track all your progress. You'll see here we have club day, check out, check out. It's basically just repeating. But a big thing is goals. Quantitative goals, numbers. Everyone loves numbers. It basically shows like what you're trying to achieve. So we've got all this. We basically list whether or not it was successful or not. As you can see here, tried tuning PID, failed. And then we have everything else we want to do. Adjust intake, switch to old code ahead of something, fix arm geometry, blah, blah, blah. Whatever you need, make sure it's written down. And because that is another big thing about the record of team and project management. Complete record of team and project assignments. Assignments, what do we see the assignments? We see the assignments on our calendar. We do write those down in our physical calendar. Personally, we are going to switch to digital next year as it is easier to manage. Big thing is digital calendar is pretty awesome because all you got to do is you just take a screenshot of that calendar and upload it. I personally don't recommend using your school calendar unless you're able to hide the assignments from your classes and stuff. But this will allow you to basically just show project management. And I think it's one of the best things you can do as a team is keep each other accountable, know whose job is whose, and get everything done on time. Because if you can see, I don't know if you guys remember, but January, February, we had like several competitions in the span of several weeks or a couple weeks and stuff. And you have to be able to like lay everything out and get it all done quick. That's why taking your robot home over the weekend is pretty big. So you really need to be taking your robot home if you can. And also, goals are massive. Like I said, because it allows you to check your robot home. That's just for our club, obviously. Notebook format, kind of like it's really general. I know in our Discord we have a lot of different notebooks you can look at. If you also search up different notebooks online, you can view those. But for the common format that our team does is just massive. What's your first thing you're doing? It's usually all the same as test solution or design modification or brainstorm. That's the first thing. Bold, all caps, and then you move down and you do the subsystem, like what subsystem are you doing or what are you doing. Then usually we do a goal, and everything here is kind of like general to depending on what you're doing. But if you do want to emphasize something, make sure it's bolded, and then everything else is just regular color. Now, pictures are kind of depending on like what size your pictures are. You'll see here that ours are usually it's the line of text and then the pictures underneath it. You want to emphasize the pictures more because that's going to make more sense than just sitting there and reading. But you'll look here that we have several pictures, and it really depends on what format you think looks best to you guys. It's really iffy because I know for us this year, we had a lot of success with our notebook, but then it came to the state championship, and we heard that it was hard to read. Uh, so I guess it's really depending on the judges. So you really want to try to maximize your notebook and make it good across all judges because judges change, biases change, readability changes. So you just want to really maximize your notebook as much as possible. Does anyone else have any questions? Yeah. Okay, so I think that the identifying the problem, like going down the list of the engineering thing as well, is the best because your notebook should already be in date. As you do everything, the process, like you shouldn't be testing your solution before you even build it. So like it's already going to be organized via your date. As you can see, like if you look down at right here, we changed the date. Like you'll see it changing. And this is the digital, obviously, the physical is different, but we go through the entire design process, and as all that changes, so does the date. So that's, I think, you don't really need to worry about organizing via the date. Does anyone else have any other questions? All right. Do you guys want to go over interviews? Okay. So this is the rubric. Most of the interview is they're either going to one ask you questions, and occasionally they'll just be like, "We're the judges. Do you guys want to tell us about your team?" And you've got to be prepared to either one answer their questions or two go free flow and go through everything you want. Uh, for our team, we started off first with the engineering design process because that's the number one thing, and then you have to be able to be flexible because occasionally you'll talk slow or you'll talk too fast, and you need to know like who's going first. So common for our team is my teammate who does the building talks about the building, and then he'll pass it over to me because I do data analytics that goes into the test solution part, and then we'll switch it over to whoever's next. Usually it's Colin, which is our coder, and we had the special innovate submission. So you guys need to be able to choose who goes first and practice, practice, practice. If you get a mentor, that would be amazing to help you out. I know for us, before the day before our competition, the day before our interview, we had a judge from the FRC, and you basically just do a mock interview, and you sit down and you analyze what do you think you should change, what went well, and is there anything that doesn't need to be changed but needs to be improved on. That also goes along, which is very similar to the match analysis. You need to be able to analyze your interview. After interviews, at matches and stuff, if you have time, you should be able to sit down and just write everything out. And if you wanted to change anything, how would you change your answer? This really helps you just like practice, practice, practice absolutely everything. Uh, so you need to be able to go through your entire design process. Then you need to be able to go through everything in the engineering notebook rubric. Obviously, uh, that's the skills, that's the strategy testing, that's like literally coding. You want to talk about your sensors. If I pull up the Vex World's questions that we were asked not too long ago. Oh, this is the Q&A, man. Sorry, I should have had this prepared. Team interview tips and sample questions. So we'll look at this. This is something you should look at every time. This is basically just a general overview, and you should be able to answer all these questions. Has your game strategy been effective? How and why? This isn't a question I don't believe we've ever been asked, but they do ask you, how's your game improved? Sensors, pretty much all that. And you need to be able to talk about it, obviously, but talk about it in clear voice. Don't go super fast and speed through in absolutely everything, and don't go too slow, or you're going to be wasting your time for your other teammates. Because if your builder has like most of the part and you need him to talk about it and he's talking really slow, your guy talking about coding is going to have like 30 seconds or like 2 minutes, and those 2 minutes are going to eat away from the guy that has like a 30-second thing, and then that's going to get wiped out. But like that 30-second thing is pretty important. If you look at our, I think it was Bellingham, we I think we got cut off. Yeah, we got cut off at one of our matches and one of our interviews, and it's because you've got to be able to balance your time effectively in the interview. Talk clear, obviously, and I do recommend if you have a team uniform, wear the team uniform, because there's been several times where I'll be during matches and stuff, and someone's trying to talk to me, and I'm like, I don't know if you're on my alliance or you're not on the other alliance. You need to be able to like represent your team. If you can get custom shirts, I mean, that's pretty dope. But usually just wearing like whatever your club shirt is, or have something like you can be able to identify yourself with. I know Bellingham, city local, they just wear flannel. Like you can see, like anytime anyone ever wears flannel, like red flannel, you immediately think, oh yeah, that's Bellingham, because they have something you're able to recognize them by. If you're just a guy walking around in a plain gray t-shirt and your teammate's over there sitting right next to you in like sweatpants and a black sweatshirt, I mean, no one's going to even recognize you unless you like get yourself out there and talk to people, which is another big thing. Is you need to be able to socialize, build up your social skills, whether that be online or in person. Try to connect with other teams, advertising yourself to other people, record your robot and stuff, and like for matches, obviously good. Autonomous when you're practicing, so you can send that out to other people, so you can show it to people when they ask, like, hey, can you tell us about your autons? Because the one thing is if a person doesn't know you have a good auton, the chance they select you is really low. Because I know there's been times where people select like people and they're like, yo, how's your auton? And you say like, oh, what's good is good. It hits like 90 out of 100, and it actually hits like 20 out of 100. They're going to hate you afterwards, and they're going to be like, yo, why'd you lie to us? We just sold that match because of you guys. So you need to be able to basically support everything you do in robotics, including advertising to other teams about your skills. Anything else? Hello? All right. Huh? It is not good, because if you don't do it well, they're going to find out. But there is sometimes where they're like, you get asked a question and like you know the answer to it kinda, but like you don't. We had that happen to us. We actually had this guy come up to us and he was like, how can you prove this is structurally sound? We're like, we've never been asked that question before, so we were just like, we started talking about how we used like I think Chris, one of my teammates, he used the Proton or some type of CNC, and he was able to cut it, and they give you like a material breakdown and basically how much force it's able to resist. So you've got to be able to know the answer, because if they ask you more in-depth questions and you're just blabbering, they'll know you didn't actually practice any of this, and they'll immediately probably just mark you down. So it's best to always know the answer, or at least know like 3/4 of the answer.